Welcome back to Plastics in Society, the only college course that does polymer science while also critiquing polymer science. I was on vacation last week, so I didn't have time to produce a stunning lecture on the process of injection molding. Luckily, I don't have to, because other people already did that for me. Linked in the description are videos from some very nice white guys whose videos you should watch if you want an in-depth technical look at injection molding. Listen, I can't do all the work here. Injection molding is responsible for so much of the plastic that surrounds us, from the housings to electronic parts, to computer keycaps, to bottle caps, to plastic cutlery, to those model plane kits, to lawn chairs, to Lego bricks, although these are actually Mega Blocks because Nintendo is always super weird about who they collab with. Even my big bin o plastics that I take to class was made by injection molding, if you can believe it. Our lives would not be the same without injection molding, so it's worth knowing how it works if we're going to understand polymer processing. As you're watching these videos, try to recognize the telltale signs of injection molding in the objects around you in everyday life. Parting lines, ejector marks, date wheels, the section that broke off from the runners and gates, etc. Enjoy the content, and I will meet you back here in like 15 minutes. Bulbasaur. Hi. Wow, that was so fun. Injection molding is pretty cool. If you want to dive deeper into the technical aspects of injection molding, all my slides from my polymer processing class will be available online, or I can email them to you upon request. Also, you should absolutely come to office hours. Hopefully, you're gaining an appreciation for the plastic in your life and what it took to manufacture it. I'm a big old nerd, and I love being able to tell how something was made. I find it really empowering to know when something was made with compression molding versus injection molding versus thermoforming. Here on this big plastic lid, you can actually see the sprue gates and the ejector marks right there. If a cup has a little nub in the bottom, that means it was probably made by injection molding. If not, then it was probably made by thermoforming. I love this stuff. It's like a little puzzle I can solve. Now I've been caught in 4K as a Duncan enjoyer. That said, this is a class about pollution, so we're going to have to change gears here. You don't need me to tell you that there's a massive plastics crisis, with environmental pollution in landfills and waterways being the most obvious consequences of our over-reliance on plastic. Where did pollution come from? Not just physically, literally, where did it come from, but philosophically. How did it become normal for us to use something once and then throw it away? Let's look at the past, way in the past. For thousands of years, humans had to live in community with nature, learning how to hunt and gather, living with the animals they tamed, eventually settling down, usually in areas lacking in the natural disasters, and learning from plants to create agriculture. Societies were communal and egalitarian. There was little need to force oppressive social roles on women, for example, since women were important parts of the community. Life was an everyday fight to survive. Every community had to rely heavily on each other, had to count their food so they didn't eat too much, and had to use only whatever water and raw materials they could find within walking distance, meaning that waste was unimaginable. If ancient civilizations had the same relationship with nature that we do now, throwing things away once we use them once, they would have died pretty quickly. When did we shift from trying to be one with the environment to absolutely terrorizing nature like we're doing now? Hint, hint, like we talked about last week, just ask who we is. If we want to understand pollution, we first need to define terms like the environment and nature. That might sound simple enough. Nature is the outdoors as opposed to the indoors. Nature is that thing you see outside your apartment window or outside your city limits. The environment is always over there, away from people, away from homes, away from Taco Bell locations. But as we know, severe damage to the environment has consequences for people everywhere, whether they're sitting indoors or not. This separation between the natural world and the civilized world is a pretty new one, at least in historical terms, and it's also one that's pretty uniquely Western. Consider how normal it is for the powerful to see land as a resource to be extracted from, as a sink into which we can pollute with impunity, and as divisible. These parts of nature should be protected, where these parts can be polluted. It's really hard to abuse something that you consider yourself to be a part of. So at some point in history, those who wanted power over land first needed to divide themselves from land. The shift from living with nature to waging war on it didn't happen overnight. It was a gradual shift over many centuries that coincided with the creation of a new world order. Streeter and Phelps, two engineers who studied the Ohio River in the 1920s, obviously didn't invent colonialism or industrialism, but their work on oxidative stress is just one example of how colonial viewpoints can infiltrate how we do science. A river is a notoriously complex thing, but they tried to describe the Ohio River in terms of just flow rate, volume, temperature, time, and the oxygen levels of the water. This is so commonplace in the modern scientific world that we wouldn't even think anything of it. But consider how all these variables might be entangled with one another. Then consider how entangled these are with about 1,000 other factors, measurable and unmeasurable, all of which dictate how oxygenated a river is. Factors like how the river smelled, fish population, fish health, the water's color, whether it was nice to swim in, weren't considered. Today, we consider dozens of different environmental impacts when we're doing life cycle assessments, which is great, but it still fundamentally assumes that something like a river or a forest can be reduced to a set of variables. This is only possible if you perceive the world as a set of inputs and outputs, rather than a complex series of relationships. Then you get to their hypothesis of self-purification. Using data collected from the Ohio River between May 1914 and April 1915, Streeter and Phelps created a model which supposedly showed how over time rivers can eventually self-purify given enough time. River water needs a certain amount of oxygen in order to metabolize organic waste, or in layman's terms, clean up the stuff that humans and other species dump into it. So here's what they came up with. You can point to any of these plots and say, okay, if the oxygen deficit is this much and the oxygen demand is this much, the river's oxygen levels will be back to normal in this many days, and the river will thus be clean. Except there are these oxygen sags, where if the river is sufficiently low on oxygen, the river will never be able to self-purify on its own. This level of contamination, Streeter and Phelps reasoned, was the point at which the river became polluted. As long as you pollute less than this amount, don't worry. Over a long enough timeline, the river will be fine. Hopefully you can see why this is a dangerous viewpoint. For one thing, Streeter and Phelps claim that this phenomena must apply to all rivers, without actually checking all rivers. This is the key difference between Western science and indigenous science at play. The idea that a measurable phenomena in one place must hold true for all other places. It's the opposite of seeing knowledge as local, situated, and related to place, and it involves what scholar Donna Haraway referred to as the God trick, or claiming to be able to understand the world in purely objective terms. This model of pollution also assumes that nature is robust within limits, which doesn't hold true for all types of pollutants. Consider a simpler example of physics, a ball rolling down a hill. If the ball is on a totally flat plane, then a sufficiently large push will send it rolling in a particular direction, but slowly and maybe unpredictably. If the ball is on top of a hill, then any movement at all will send it flying down the hill uncontrollably. If the hill is in a deep valley, that ball isn't going anywhere, no matter how hard it's pushed. Or if the ball is in a shallow valley, it can be pushed around a little bit, but if it's pushed past a certain point, it too will go rolling down the hill outside of our control. We can view human intervention in nature in any of these ways. Nature is either capricious, unpredictable in the face of human intervention, fragile, completely unable to handle human intervention, robust, it can handle anything we throw at it, or robust within limits. It can take a little bit of pollution, but not too much. These days, few people would admit the environment can handle literally anything we throw at it, except maybe the most evil of oil executives. Most would say that nature is robust within limits. But hopefully you're already seeing who this view of nature can benefit and who it can hurt. A simulative capacity is the idea that there is some threshold under which nature can handle an amount of pollutants, but if you pass that threshold, you're in trouble. This is how most modern pollution science works, including for plastics and the other products of fossil fuels. The question is always, how much carbon can we pollute? But we should consider that this type of mindset doesn't work for all types of pollutants. For things like radiation or carcinogens, there is no safe dose. Just a little bit will definitely kill you. Or consider more complex interactions, like how an animal's immune system might be able to deal with instantaneously low levels of arsenic, but chronic low levels of arsenic can damage entire populations of species over long periods of time. Or just consider plastic and the many additives that go into it. For example, bisphenol A is a common additive in polycarbonate water bottles, and in doses as low as 1 part per trillion, it can damage your endocrine system for a long time. For perspective, 1 part per trillion is equivalent to a single drop of water in 18 million gallons of water, or a single second out of 32,000 years. Many plastic additives, like the phthalates used in PVC, are endocrine disrupting chemicals, and the endocrine system is notoriously finicky. We'll talk about this a bit more next week when we read chapter 2 of Max Liboiron's book, but the short version is some chemicals can harm you even at very small doses, or they can harm you at small doses but not large doses. Turns out, things are complex. What we now know about the endocrine system, as well as numerous other complex relationships within our bodies, is that plastic is not a threshold pollutant. Microplastics can enter our land, our water, or our air during all phases of plastic's life cycle. Heck, even the concept of microplastics, a source of pollution that's notoriously difficult to clean up and near impossible for nature to self-regulate, defies the very idea of assimilative capacity. On an even more fundamental level, pollution is about power, specifically about the power to own land. The idea of private property is a key part of our modern culture, and it's inherently tied to colonialism and capitalism. I own this piece of land. Says who? A piece of paper? The government that enforces property law, usually through violence? In a way, it's all made up, and it's made up in a way that lets the powerful, the owning class, the plastics industry, big oil, decide where it's acceptable to pollute. They make sacrifice zones by buying up land and designating it as for pollution, as though the purpose of any land should be to dump humanity's waste. There's a lot to be said about primitive accumulation, the process of turning land that was being used as commons into land that was used as resource. Leftist writers from Marx and Engels to Silvia Federici have all written about enclosure as a means of land control, but also social control. How do you convince a communal society to adopt a value system of extraction? You tie extraction to morality, convincing the population that if they don't work, they're lazy, and that not using the land to its full potential is akin to sin. The best, most accessible introductions to this topic of private property and how it first came to be that I've personally found come from these YouTube videos if you want to take a deep dive into this. But short version, private property is inherently linked to capitalism and colonialism, and that means it's linked to pollution. So how does this affect the ways in which we do our science? Well, we can start with questioning the ways in which we reduce the world into simple, measurable categories and apply universalism to insist that something true in one place must always be true. It can also mean looking deeper into the things we take for granted. Consider the story told on page 65 of our course book about how the Clear lab once ordered potassium hydroxide. They ordered the KOH, threw it in a waste bin, and then it went somewhere else. EH&S came, picked it up, and whisked it away, out of sight, out of mind, much in the same way that we do to plastic cutlery and bottles every single day. These modalities deserve to be questioned, and we can envision a different way of doing science that minimizes harm to the environment. Because, as I've hopefully established by now, we are not separate from the environment. One of the final takeaways from this chapter that I want to highlight is this study, which claims that the majority of plastic enters the oceans from China, Indonesia, the Philippines, Thailand, and Vietnam. The mainstream media a few years ago, when this study was first published, took the story and ran with it pretty much uncritically. You may have even heard yourself that the highest plastic polluters come from these few developed and developing Asian countries. But as enlightened scientists, we can take this survey data and we can start asking who questions. Questions like, why are we so obsessed with blaming China and other Asian countries for plastic pollution? Could it have anything to do with the fact that China is the major economic competitor to the US? Or maybe it's just plain anti-Asian racism. Also, what's being ignored with this data? The study itself actually didn't discuss a number of really important factors, like how it got its numbers, whether per capita waste measurements even show the true problem, industrial and manufacturing scale waste from production, transport, and construction, and the fact that we've talked about in the last lecture, which is how pollution is an industrial production problem, not just a consumer problem. One of the conclusions that the authors of the study reached was also that we should solve the plastics crisis by burning plastic, which, as we'll talk about in the coming weeks, is not a very good idea. And yet, this study was reported on super widely and uncritically, more than most other studies on plastic pollution in that year. Like we've covered with the disabled community in this class, we must remember that discussions of plastic pollution that don't center all voices can cause harm. Capitalism is a global world order that all industrialized countries, including both China and the United States, are complicit in. We can and should turn our attention inward to our own harmful practices without always pointing the finger at other countries. If anything, we should be sympathetic to the countries outside of the US imperial core. The United States exported around 950 million pounds of scrap plastic in 2022, a decrease of about 20% from previous years, but still an incomprehensible and violent amount of trash to dump onto other nations. As a result of generations of exporting our waste, entire countries have to deal with the fact that their land, their mountains, and their rivers are now just landfills. The United States owning class got to decide how their land gets used, even though their land is thousands of miles away from where any of them will ever step foot. Pollution isn't just an unfortunate side effect of capitalism and colonialism. Capitalism and colonialism require pollution. This life that we in the West live with shiny plastic that we barely notice surrounding us at all times doesn't just result in pollution elsewhere. That's the cause and effect put backwards. Our lives are only possible because other people have to live like this. Now, I know what you're thinking. Dr. Anna, surely there's something we can do about this. What if all our plastic didn't have to become someone else's pollution? What about recycling? What if we take all our waste and reforge it into new materials? Why does all this violence have to take place? Well, let's just say there's good news and bad news. Next week, we'll finally talk about recycling. We'll look at the world of bottle production, fast fashion, and so much more. And we'll talk about how plastic recycling actually works, what the challenges to recycling are, and most importantly, who is most responsible for it.